equation is 3p squared minus 2p plus 3 minus p squared minus 7p plus 7. You need to distribute the negative. So you're going to change the signs. If it's a negative and a negative to a positive. If it's a negative and a positive, you need to transform it to a negative. You need to then rewrite the equation and take out the parentheses. So it becomes negative p squared plus 7p minus 7. After that, then you need to collect like terms. They're shown in purple. The first term, the second term is in blue, and the third term is in red. Once you collect like terms, your final answer is 2p squared plus 5p minus 4. Second equation is addition, 2a plus 4c plus 8, and then 7a minus 9c minus 3. Now you want to carry out the plus and get rid of the parentheses, which leaves you with 2a plus 4c plus 8 plus 7a minus 9c minus 3. Now the second thing that you need to do is you need to collect like terms. First term is in pink, second term in green, and third term in blue. The answer to the equation once you collect like terms is 9a minus 5c plus 5. Note! Remember, the step solving an addition problem is, or a subtraction problem is to first take off the parentheses. Second, look at the signs. Make sure you carry them out. And third, group like terms. Then fourth and final is simplify. Now, reasoning whether two polynomials or expressions are equivalent. Now to first figure out whether these two equations are equivalent, the first way, or one way that you can figure it out, is to simplify. To simplify the first equation is you collect like terms, first term in purple, second term in red, third term in blue. You collect like terms, then you simplify it and add and subtract them to get a final result, which is 2n squared plus 2n minus 9. Now, you do this the same way for the second equation. Now, don't forget to distribute that negative between the 1 and the negative 2 squared. You need to collect like terms, and the final answer for that is 2n squared plus 2n minus 9. Now, here's our two equations. The first one is on the right, and the second one is on the left. Now, you see that the answers are the same, therefore, the function fn equals g. Now, the second way to find out if equations are equivalent is by substituting numbers. For example, let's say that x equals 0, y equals 1, and z equals 0. Now you're going to plug in those numbers into the equation. So you see that the first equation does not equal the second equation. So the expressions are not equivalent. Note, one way you can figure out if equations are equal is to simplify. The second way is to substitute a number into the variables. Now, two polynomial functions are equivalent if they have the same function or expression, or they produce the same graph. They are not equivalent if they do not have the same values after they are equivalated with the same numbers substituted for the variables. So if they do not simplify to the same equation or if you plug in the same numbers, if they do not equal the same, then they are not equivalent. Multiplying polynomials. There are three ways you can multiply polynomials. The first way is the commutative property, or to see if they multiply. You realize that AB equals AB, or AB equals BA. The second way is the associative property. A times B times C equals A times B times C. And the distributive property. A times B plus C equals AB plus AC. Sample problem is to expand and simplify. X minus 6 times 2x plus 5. The first thing that you can do is you can multiply x with 2x, x with 5, negative 6 with 2x, and negative 6 with 5. Write down the equations. Don't forget to write them down. That's important. 2x squared plus 5x minus 12x minus 30. You combine like terms and you get 2x squared minus 7x minus 30. The factoring polynomials. You can see that the first term, 4x squared, and the third term, 25, are perfect squares. Now when you write these out, you square root the first term and the third term. Then you need to add the signs. Now since this is a perfect square, the signs are both pluses. So your final result is 2x plus 5 squared. Simplifying rational functions. 5x plus 3 over x plus 3 times x minus 3. Now when you have a multiplication problem or a division problem, you can cancel the common factor, which leaves you with, if you cancel out the x plus 3 and the x plus 3, it leaves you with 5 over x minus 3. The restrictions are x cannot equal 3 because that'll make the denominator 0, and x cannot equal negative 3. Restrictions. The denominator cannot be equal to 0 because it would be undefined. Now, here's an equation. You need to divide both by a common factor. You can take 3 out of the top and 4 out of the bottom. Okay, you need to cancel out the common factors. And you can cancel out the top n with the bottom n, and that leaves it 3n over 4 times 2n minus 1. Now, your restrictions for this problem is n cannot equal 1, n cannot equal a half, and n cannot equal 0, because if any of these n's were these numbers, it would make the denominator 0. Multiplying and dividing rational expressions. I have 2x squared over 7 with 21 over x. Now you can cancel out or take away the common factors, and it leaves you with 2x over 1 and 3 over 1, which gives you 6x. Now the restrictions for this problem is x cannot equal 0 because that would leave the function undefined. A way you can divide expressions is the first step that you need to do is you need to flip the second part of the equation, or the divided part, and have the denominator go on top and the numerator on the bottom. Now you cancel out common factors, and your answer is left with 3. Restrictions is x cannot be negative 2 and 2. Make sure that your restrictions and divisions are both from the numerator and denominator of the second part of the equation. Addition and subtracting rational expressions. 3 over x minus 3 minus 7 over 5x minus 1. Make sure when you're adding and subtracting that the denominators for both parts of the equation are equal. For the first part of the equation, you want to times by 5x minus 1. The second part, you want to times by x minus 3. Now once you distribute, you will get this 8x plus 18 over x minus 3 times 5x minus 1. If you simplify it even more, you'll get 4x plus 9 over x minus 3 times 5x minus 1. Your restrictions are x cannot equal 3, x cannot equal 1 over 5. Note: the first thing that you need to do when you're adding and subtracting rational expressions is to find the common denominator. The second thing you need to do is you need to simplify and factor by the common number if there is any common number. Third thing you need to do is cancel out the common factors and then write your final result.
Exploring the graph of rational functions.
Okay, you have the equation x squared plus x minus 2 over x squared plus 4x plus 4. First you need to factor the trinomial. Now you need to cancel out the common factors, which is x plus 2. The restrictions value of the canceled denominator will become a whole in this case, which is x equals negative 2. Now, to find the whole point, you plug in the value of x into the last part of the function, and it will give you the y value. Now, when the x value is plugged back into the function, you'll get an error. Now, the remaining denominator that you have will become the vertical asymptote. Now, when you're doing the horizontal asymptote, you look at the points that matter. The other points become negligible. Now, the main point or the bigger x's of this function are the x squareds. In this case, in this function, the x squared over x squared, if you plug in a number, it will give you 1. Now, when you have a 1, that means that your horizontal asymptote is a 1. Our second example, we have x squared plus 7x plus 12 over x squared plus x. You'll need to factor this trinomial, which gives you this. You need to cancel the common factor. Now, the common factor is x plus 3, so the whole is x equals x is negative 3. To get the whole point, you need to plug the negative 3 back into your equation. So that gives the whole negative 3 and 1 over 5. To find the vertical asymptote, you must see what denominator is still remaining, which is x minus 2. So the vertical asymptote is at 2. Now, to find the horizontal asymptote, you look at what x's you have. You have x squared over x squared. If you plug in 1 or if you plug in any number, that x over x will give you 1. So your horizontal asymptote is at 1. Note:
Remember, if you want to find a horizontal asymptote, what you need to do is to look at this equation in which y is equals to ax to the n power over bx to the n power. If m is equal to n, the horizontal asymptote is a over b, which is the coefficient. If m is bigger than n, the horizontal asymptote is none, which is there won't be any. And if m is less than n, the horizontal asymptote is 0.